To understand modern large language models like Llama 3 or Mistral, we have to look beyond the hype and into the architecture. It starts with a single token ID. This discrete number passes through the embedding layer, which acts as the gateway. From there, it enters the massive transformer block. While attention gets all the headlines for connecting words, today we are diving into the MLP, specifically the SwiGLU layer. This is the silent engine, where the model actually thinks and processes facts. But before we process, we need a format the math can understand. The embedding layer is essentially a massive lookup table. When token 4092 comes in, we do not calculate anything yet. We simply fetch its corresponding row from the matrix. This extraction gives us vector x. This vector represents the static meaning of the word ready to be transformed. In research papers, you will often see simple boxes labeled capital W. Do not be fooled by the simplicity. These boxes represent linear layers. Inside, they are dense webs of connections, matrix multiplications, that project our vector into higher dimensions. Every time we say project up or expand, we mean passing data through this massive grid of neurons. Now, let us look at the mechanisms that make modern models so smart. First, the activation. We use Swish, also called SwiGLU. Unlike the old ReLU, which killed negative values completely, Swish allows a tiny bit of negative flow. It is smoother, making learning more stable. Second, the gating mechanism. Think of this like a valve. If the network decides certain information is irrelevant to the current context, the gate closes, effectively zeroing out that signal. Now, let us assemble the full SwiGLU architecture. Our input vector x splits into two parallel paths. On the left, the feature projection, W sub u. This contains raw facts and content. On the right, the gate projection, W sub g. This calculates what is important. We apply the SwiGLU activation only to the gate. Then the magic happens, element-wise multiplication. The gate overlays the features. It filters out the noise and keeps only the relevant knowledge. Finally, we project this filtered insight back down via W sub d. This is how a machine learns to select the right facts for the right context. From static lookup to gated reasoning, that is the journey of a token.